This is Mrs. Benke, and in this set of notes we will begin to explore how we translate the balancing block activity that you did into how to balance actual chemical equations. All right, let's take a look at some of our vocabulary that we will be using when we talk about balancing chemical equations. To the left of the arrow, we have our reactants, and reactants are what we put into a chemical equation. To the right of the arrow, we have our products. Our products are what we get out of a chemical equation. And what separates the reactants from the products is the arrow, which is the yield sign. And this is what is basically the same as an equal sign is in math. We have two sets of numbers that we use when we're balancing chemical equations. The large number that goes in front of the formula is called a coefficient. The coefficient is what we use to balance our chemical equations. The small number that comes after a formula is our subscript. And just like when we were talking about writing formulas and we couldn't change the subscripts with the polyatomic ions, in a like way we cannot change the subscripts when we're talking about balancing equations. They can't be changed at all. We have to leave those alone. The only thing that we can do is add these coefficients in front of our formulas. There are some other symbols that you will see when you're balancing equations. If we have a yield sign that points forwards and backwards, this means that the reaction is reversible. We can also talk about what state our reactants and products are in. So if we see S, L, or G in parentheses after a formula, that means that we're dealing with a solid, a liquid, or a gas. Another symbol we can see in parentheses is AQ, which means aqueous, and this simply means that it was a solid that was dissolved in water. If we see an arrow with the word heat above it, then that means that we must heat the reaction in order for it to happen. Another way that this can be expressed is with an arrow that has a triangle above it. And finally, we can have an arrow that has a symbol like PT, or an arrow that has a formula like MnO4. Let's do KMnO4. Okay, and that means that a catalyst is added. So whatever the formula is, that will be the catalyst that was added to the reaction. And recall from biology that a catalyst is simply going to speed up the reaction without being used. So platinum and potassium permanganate are common catalysts that are added to reactions, but that don't affect how we balance the equation. One special consideration when we talk about balancing equations is diatomic molecules. Diatomic molecules, if we look at the word, it's two atoms that make up the molecule. Diatomic molecules are never going to exist in nature all by themselves because they are so reactive. So in nature, these elements, when they're by themselves, are always bonded to an identical atom. So we can't just have a single atom of hydrogen, we always have H2. Which means we have two hydrogen atoms bonded to each other. The other diatomic molecules are chlorine, fluorine, bromine, oxygen, and nitrogen. These you do need to memorize. So one thing you may be asked to do is to write an equation from words. And this is where we're going to have to go back to our previous chapter and look at how do we write formulas. So let's take a look at our example. We have zinc plus lead 2 nitrate. Now I know lead 2 is Pb plus 2. Nitrate is NO3 minus 1. So when I crisscross them, I get Pb, NO3 in parentheses with a 2. It's going to yield zinc nitrate. Zinc is Zn plus 2. Again, nitrate is NO3 minus 1. When I crisscross those, I'm going to get Zn, NO3 in parentheses, 2. So when I write my balanced equation, I'm going to have zinc plus lead 2 nitrate yields zinc nitrate plus lead. Now what I need to do, instead of counting blocks, I need to go back and forth and count my element symbols. Okay, so on the left I have 1 zinc, and on the right I have 1 zinc. On the left I have 1 lead, and on the right I have 1 lead. On the left I have 2 nitrate groups, and on the right I also have 2 nitrate groups. So that tells me that this equation is already balanced. I want to make sure that I indicate that an equation is balanced, because if you don't write anything, I don't know if you know that it's balanced. So don't leave a balanced equation alone. Make sure you write balanced or it's okay or something like that. This also points out an important rule, and that is when we have polyatomic ions, like nitrate, that is present on both sides of a reaction, what I want you to do is make sure that you kind of look at that as a unit or a group. So we have 2 nitrates. I don't want you to break it down to figure out how many nitrogens do I have and how many oxygens do I have. That's just going to get you confused. So again, when a polyatomic ion is present on the reactant side as well as the product side, look at the polyatomic ion as one single unified group and count how many of those groups are on each side of your equation. All right, so here we go again with another example. We have aluminum bromide. Aluminum is Al plus 3. Bromide is Br minus 1. So when we combine them, we get Al Br3 plus chlorine gas. Now remember, chlorine was one of those diatomic molecules, so I have to have my 2 here in order to show that it's diatomic. So plus chlorine gas are going to yield aluminum chloride. Okay, again, Al plus 3 and Cl minus 1, so when I crisscross, I get AlCl3 plus bromine. Bromine was also a diatomic molecule, so again, I have to have the 2 there. Now I'm going to start comparing my elements back and forth just like I did in the previous example. So on the left I have 1 aluminum, and on the right I have 1 aluminum. On the left I have 3 bromine, and on the right I have 2 bromine. Well, this isn't going to work. I need more bromine on the right, but the only way I can add more bromine is if I add what's already there. That gives me 4 bromines on the right and only 3 on the left. So now I need to go back to the left to add more bromine, but to do that I have to add another aluminum bromide. This, AlBr3, is going to give me a total of 6 bromines. Now I need to go back to the right to add another bromine, which will give me a total of 6 bromines on the right and 6 bromines on the left. But by changing my number of aluminum bromide, I also changed the number of aluminums I had. So let's go to the right and add another aluminum chloride, which will give me 2 aluminums, but it changes my number of chlorines to 6. I need to fix that on the left. So I go back and I add another chlorine, which gives me 4 chlorines. I add a third chlorine, which gives me 6. Let's double check. I have 2 aluminums on the left and 2 on the right. I have 6 bromines on the left and 6 bromines on the right. I have 6 chlorines on the left and 6 chlorines on the right. I'm now ready to write my balanced chemical equation, which is 2 aluminum bromides plus 3 chlorine gases yields 2 aluminum chlorides plus 3 bromides. In this sample problem, we have sodium phosphate, so Na plus 1, PO4 minus 3, which crisscrosses to give us Na3 PO4, combining with calcium chloride, that's Ca plus 2, Cl minus 1, which gives us CaCl2. That's going to yield calcium phosphate, which is Ca plus 2, and PO4 minus 3. When we crisscross that, we get Ca3, PO4 in parentheses 2, and sodium chloride, which is Na plus 1 and Cl minus 1, which gives us NaCl. Once again, we start counting on the left and the right for each element. So on the left I have 3 sodiums, and on the right I have 1 sodium. I need to add 2 more sodiums to the right, so I add another NaCl and a third NaCl. Next, I want to check my phosphates. I have 1 phosphate on the left, 2 phosphates on the right. I need more phosphate on the left, so I add another Na3PO4. Well, my problem is that by doing that, I now have 6 sodiums, where on the right side I only have 3. So let's go back and add our balance of sodiums. So I need another NaCl, NaCl, and NaCl. So now I have 6 sodiums on the right and 6 sodiums on the left, 2 phosphates on the left, and 2 phosphates on the right. Let's keep going. On the left I have 1 calcium, and on the right I have 3 calciums. I need to balance out with more calcium on the left, so I'm going to add 2 more CaCl2s, and that gives me 3 calciums to match the 3 on the right, and it gives me 6 chlorines to match my 6 chlorines on the right. Let's go back and double check. I have 6 sodiums on the left and 6 sodiums on the right. I have 2 phosphates on the left and 2 phosphates on the right. I have 3 calciums on the left and 3 calciums on the right, and I have 6 chlorines on the left and 6 chlorines on the right. So now I can write my balanced chemical equation. And my balanced chemical equation is 2 sodium phosphates plus 3 calcium chlorides yields calcium phosphate plus 6 sodium chlorides. For my last example, I have potassium chlorate, so K plus 1, and ClO3 minus 1. When we crisscross those, we get KClO3. When heated, yield potassium chloride, which is K plus 1 and Cl minus 1, which crisscrosses to KCl, and oxygen gas, which is O2 because oxygen is a diatomic molecule. Let's compare our elements from the reactant and the product side. I have 1 potassium on the left and 1 on the right, 1 chlorine on the left and 1 on the right, 3 oxygens on the left and 2 on the right. So I need to add more oxygen to the right, so I add another O2. This gives me 4 oxygens on the right with only 3 on the left. So now I need to add another KClO3 to try to add more oxygen. But this gives me 6 oxygens. So I'm going to go back to the right and add another O2, which gives me a total of 6 oxygens. Now let's go back and double check. I have 2 potassiums on the left and only 1 on the right. Let's add another KCl on the right. That gives me 2 potassiums on the right and 2 on the left, 2 chlorines on the left and 2 on the right, 6 oxygens on the left and 6 on the right. So now my equation is balanced. To write my balanced equation, I write 2 potassium chlorates, when heated, yield 2 potassium chlorides plus 3 oxygen gases. Complete these 4 practice problems, balancing the equations, and remember to write in your coefficient. Please turn in your notes and the practice problems to Mrs. Benke, either as a paper copy or take a picture of your notes and upload them into Schoology.